Hi, I'm Chen. Today I want to present MAPO, or NIPS Spotlight paper. Reinforcement learning has recently achieved a lot of successes in playing games, designing neural architectures, and robotics. So can we use RL to generate programs? We consider the task of program synthesis and semantic parsing. Given a database table and a natural language question, can the model learn to generate a program that computes the answer? For example, to answer how many more passengers flew to Los Angeles than Saskatoon, the correct program needs to first filter out the two rows, compute the difference in the passengers column, and then return it as the answer. Annotating the right program for each question can be expensive and time consuming. So instead, we want to use RL to learn only from the final reward, whether the program returns the right answer or not, which is much easier to collect. Despite the successes, there are still a lot of challenges when applying RL. Policy gradient is one of the most commonly used RL methods. It contains an actor that generates samples from the current policy and sends them to the learner to estimate the gradient and update the policy. The gradient estimate is unbiased and will find an optimal solution for expected rewards. However, because the gradient is estimated from only a few unpositive samples, the variance is really high, which makes the training slow. On the other hand, imitation learning tries to learn from external demonstrations, using, for example, maximum likelihood training. The training is much faster, but because it is not directly optimizing the expected rewards, the final solution can be suboptimal. It also requires human supervision, which is usually hard to get. MAPO combines the advantages of the two approaches by saving samples with high reward in a memory and mix the samples from inside and outside memory. We compute an unbiased gradient estimate with low variance. So why is the variance lower? The gradient is computed at an expectation over the whole program space, which can be exponentially large. So estimating the gradient by sampling from the whole program space can have a lot of variance. In MAPO, we divide the space into two, programs inside and outside memory. If the number of programs inside the memory is small, we can enumerate them and only sample from the outside, which is a smaller space, so the variance is reduced. Even when we sample from both, it can be viewed as a stratified sampling, so the variance reduction usually still holds. We evaluate MAPO on two challenging program synthesis and semantic parsing benchmarks. On wiki table questions, MAPO is the first state-of-the-art approach using RL. On wiki SQL, while most of the state-of-the-art methods are using ground truth programs as strong supervision, MAPO only needs a final answer as weak supervision and achieved competitive results. When comparing to other baselines, we found that MAPO converges slower than maximum likelihood training, but actually reaches much better optimum, and reinforce doesn't show much progress at all. For details, check out our paper or code, or get in touch. Thanks.